Hello and welcome. This is going to be the video of my attempt at the final boss battle, so to speak, of Harry Gross's Excelopolis role-playing game, which is fighting Lana Banana. Uh, I made two attempts at this. The first one obviously was a fail, otherwise I wouldn't have tried again. Um, and I was planning to just stitch them both together into a video and put the whole thing up, but then it turned out my computer battery was getting low. It died almost immediately after I failed the first time, and the result was that um, my video like froze up quite a lot during it. So that's kind of unusable footage. So, but the second one starts from like it doesn't really introduce the case because I'd already looked at the case and I expected it to be the follow-on from this video, which is terrible. So I'm just going to kind of zip through this a little bit and explain the case and explain my approach that I did the first time round, the shortcomings, whatever, and then the second one will make a little more sense. So let's just skip through this quickly. So we get over to Lana, we talk. The problem begins, and the idea of the problem, let's go, there's Lana and the Maelstrom, which if we can get a visual of the Maelstrom, yeah, so we've got this giant whirlpool here, so it's like a 40 by 40 grid. We've got X's right in the middle, so you kind of die if you end up there, and actually you die if you end up in the 4 by 4 grid around that, so like within one square of the X. And then you've got this current that's kind of sweeping you around and around and gradually in toward the center. And then overlaid on top of that Maelstrom, you have it's shown below here. You can only see a little bit of its like starting position. So there are like 11 bananas floating in this whirlpool, and there's Lana Banana, the monkey, floating in the whirlpool. And so the idea is that the bananas follow the direction of the arrows in the cells on each move, and gradually swirl their way into the center where they get lost. Lana also follows the swirl of the current, but she has her surfboard. So in addition to being moved along one step by the current each time, she can also move herself in one. Everything is a diagonal move. So she gets swept in one direction by the current, and then she can either stay in that position for that turn, or she can move in any of the four diagonal directions as long as she's not moving directly against the current. So wherever she got swept from, she can't go back because then she'd be swimming or surfing directly against the current. But if there's anything else pointing into that cell, then she can't go out into that. But generally speaking, she can either stop where she is or go in the three other directions. Um, and so the challenge for Lana is to try to get all the 11 bananas before any of them is lost. Okay, I pulled up the full instructions here so we can look through them. So Lana, it's called Lana and the Maelstrom, or Maelstrom, I don't know. Lana Banana, famous banana lover, has come across a banana tree which has tragically fallen into the sea and is losing its bananas in a whirlpool. Luckily, she has her surfboard to hand and sets out to save those bananas. Every turn, each banana and Lana move one cell according to the arrows. Within the turn, Lana can also optionally choose to move a second time in any diagonal direction, though she cannot surf directly against the current, so she cannot surf to a cell that points back to her current location. If she is in the same cell as a banana at the end of a turn, she collects it. Bananas may end up at the same cell, in which case both will be collected if Lana ends up on that same cell at the end of her turn. So in other words, there are places where, I can't find one right now, but trust me, there are, like here, for example. Where the two different currents meet, where something can be swept into the same cell from two places. So if two banana paths converge, then they stay together after that, and you can get them both as one. Lana needs to stay safe from the whirlpool, so she cannot end any turn on a cell within a distance of one cell from any X, including if the distance is diagonal. But the important thing about the end is that you can move into this area if you can like drift with the current into that area if your additional diagonal move takes you back out, which means that you can kind of cut across the corner of this if you're careful about it. If an uncollected banana lands on an X, it is also game over and an invalid solution, so you have to get all the bananas. The starting grid at the end of turn 0 is displayed below. When Lana has a choice on when to collect a banana, she always chooses to collect it as early as possible while meeting the condition of eventually collecting all bananas. So we won't see this until later, but for example, she starts off right next, like 2 squares away from a banana, but if she goes for that one right away, then another one will fall into the whirlpool before she can get to it. So you got to prioritize. What else? There will never be a conflict scenario where she could collect one earlier by delaying another, which is not resolved by the must collect all bananas eventually rule. I think except where there's like two, where she could intersect a path in 2 consecutive places, in which case this thing about choose to collect it as early as possible kicks in. You do not have to model the full scenario as a traveling salesman. Even supercomputers cannot do this. It is not recommended that you build a question like this at home. It is a freaking nightmare to make a specific banana set that was solvable in Excel. Most banana sets are not, but this one is. But that's in the past. Now this is your nightmare. This is an allusion to the fact that I think Harry said he got this idea and started working on it at like 6 p.m. And worked on it, like built the entire question from scratch in one session through to like 5 a.m. the next morning, which is insane. Answer with a binary string with a 1 indicating a turn when Lana collected at least 1 banana and a 0 a turn when she didn't. Don't include turn 0. The first turn is turn 1 when everything is moved from their starting position. The final digit should be a 1 to indicate the last banana being collected. And so this is an example answer. And it also mentions the banana whirlpool is quite hypnotic and may distract you during your solve. This was actually an extra like visual overlay, which didn't work on my computer, but I saw it on Bo's video of this problem after, that there were like bananas swirling around the screen. It was kind of hilarious. Anyway, okay, so that's the setup of the problem. Now let's quickly go over what I did. So my usual thing, first I set up my kind of number grid that's 100 times the row number plus the column number, so that every address has a unique reference. I pulled out the addresses of all the 11 bananas, and then I said, okay, where are they going to end up on each subsequent turn? That took a little bit of work. Just okay, this arrow is adding 101, this arrow is minus 101, minus 99, plus 99. On an X you stay still, and then you can kind of propagate that to say, okay, well, eventually these things end up all in X squares, which is what there's like 1921, 2022, all of those are X squares, which is why it's not moving from turn to turn. So then I tried to make it into an X and pulls it up for a minute, but basically worked. So yes, now we have X's if they end up in the X, and then based on that you can figure out how many turns it takes and which banana gets lost first and so on. Then the next thing to do was figure out where Lana can be on every turn. So Lana starts off on 2929 in my notation, and then she can get to any of these places on the next turn, and then I kind of flatten that out into, at some point when I'm done with this formula obviously took me a little while to write. Let's go back. Where we go? Yeah, okay. So then this flattens out into, these are all the places she can get to. So this is turn 0, the start. This is all the places on turn 1, turn 2, turn 3, turn 4, and so on across, out as far as the last banana sinking into an X, because there's no need to model after that. I thought this would totally explode, but it turned out it wasn't too bad. There were about 500, 600 locations she could get to at that point. And at that point, I was kind of scratching my head. I was like, okay, I've got all this kind of growing, massive set of locations that Lana could be at. I've got all the banana locations. So I started playing around with the visualization. So I made all the bananas yellow. That was totally irrelevant. But then I added some conditional formatting here based on a turn number up here to say, okay, highlight in yellow all the cells where a banana is on that turn. And then I could manually, then I was setting up another rule for Lana. Yeah, so this is now highlighting whatever on turn 6. This is where all the bananas are, and these are all the possible places for Lana to be. And what I was looking for was, is there a banana that falls in with only one kind of possible overlap with Lana? And I was kind of messing around a bunch here, but basically I think this one was it. Let's see if we can... no, I was changing it too quickly, but anyway. Oh yeah, so look, you can see that yellow one goes in at turn 9, so then I'm kind of backtracking from there to figure out, okay, so, by turn 7 or turn 8 or whatever it is, you have to get that banana. And then what I started to do from there, oh yeah, so at this point I also realized that I had allowed Lana to move through the whirlpool, which is why I turned that. So yeah, you can see here, I've got her going straight through the whirlpool as interim steps, so then I had to go back and fix things to exclude those possibilities. So that took another while. And then I was just trying to figure out, okay, on a given turn, she has to be in a given location. So yeah, that was this one here. To get this banana, there's only one way that she can get to it. Because look, you can see she's about to go into, this banana will go into the whirlpool on the next step, or go into the 4x4 around the whirlpool that you can't get into. So you've got to get that. So then I figured out, all right, where are we? Yeah, so I said on this turn you have to be at 1919, and then I tried to kind of back into where could you, the video has gone really super slow by now. So yeah, you can see from 1919, there's only some places that you can go on to, and then I tried to figure out backtracking from there, because this says there's like whatever 50 different locations you could be in, but there's only a handful of locations that could get to 1919 on the next turn. So I said let's constrict it based on that, with partial success, and then I had to change my format to work with that. And as you can see, I was kind of running out of time. All right, and the video is like totally frozen from there on. But that's basically what I got done in the first go round. It's 45 minutes. It goes by very quickly when you're zooming through here and when you've tried it again after. But that was the attempt, and I think that's enough of a lead-in for you to understand what I'm doing now when I flip over to the second attempt that actually did come out properly. So over to that one now. Okay, it is a little later in the day. Apologies if you can't see me well. I'm lit from behind, but that's just where I am. Gonna give this another go. So what did I learn from last time? I think my basic approach was not bad. I want to figure out where the bananas are going to be on every turn. I want to figure out where Lana can be on every turn. And then I think what I need to be a little more attuned to from the start is, first, I should X out the bananas as soon as they get within the range of the whirlpool, because then they're gone. But second, I think what I need to look for right from the start is how many points can Lana reach each banana at? Because I think what I found playing around with it visually, but quite kind of manually last time, was that there were some pinch points where like the only way to get this one particular banana was at this one particular turn. So I'm going to try and be more systematic about finding those pinch points, the only place that Lana can get a banana. And then the other thing is, I had this sort of forward propagation that said, okay, if you were able to access these cells on the last turn, then these are the ones you could get to on the next turn. And I had a backward propagation that said if you have to end up in this cell on the next turn, these are the ones you could have come from. But what I really need to be able to do is put those together to say, if you're starting from here and ending up here, then it's going to be the sort of the intersection of those two. I thought about trying to do a sort of circular references style, like look ahead and look back, and I decided I don't think that's going to work. So what I'm going to do instead is I'm going to build up all of Lana's possible locations in one spot, and those will each be a dynamic array anchored in one row. And then once I figure out where I'm pinched at, where I have to, like, for example, I think on turn 7 there was one particular place I had to be. So then below that I will set a value for turn 7, and then for everything after that I'll use the forward propagation formula. But then for everything before that, I'm going to say if you can reach it by taking a step back from where you have to end up, and if it exists in the things that you can already reach in that column. And I think that way I'll have a few different pinch points, and there'll be only one place I can get one banana, and then once I pinch to there, then there'll be only one place I can get it. I think it's going to fall out that way, but I don't know. There may be more to it than that I just haven't reached yet. But anyway, enough yak. Let's go. Yes, 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 yes. Such foul language. Okay. So, first thing that I want is to flatten the maelstrom. So we'll say to call of this. And then we'll say unique of that. Okay. So we're going to say this one is minus 99, this one is 101, this one is 99, and this one is minus 101, and this one is 0. Okay. And then I want the locations of each of these, which is going to be to call sequence 40 times 100 plus sequence comma 40. Okay. So that's where each one is, and then I guess I want also where each one. So this is location, contents, direction, and then next, which is going to be just equals this plus this. Okay. And then I want to know which ones are actually in the maelstrom, right? So how am I going to do that? So I have to find X. So it's 19, 21. No, sorry, it starts at 18, 20. So it's going to be sequence 4 starting at 18 times 100 plus sequence comma 20. Sorry, not sequence comma 20, sequence of 4 values starting at 20. So yeah, 18, 20 at the top left, that's good. Sorry, no, and then I want to wrap all that in a to call. Okay, so then whirl. That's going to be, let's see, just do match this against that 0. And then all of these are yes, and all the rest are no. Still don't have is number or is error or anything like that. But anyway, alright. So I think that's kind of my setup there. So now I need to figure out where the bananas are. Oh, I should have kept the formula for that, never mind. Okay, so I'm going to say to call if this equals this, then sequence 40 times 100 plus sequence comma 40, otherwise 1 over 0, 3. So those are my starting banana locations, and then let's just do the same thing for Lana. And Lana is this. So it's equal to this. Okay. Alright. Yeah, that's fine. Doesn't matter. Okay, so now we're going to say if this equals x, then carry on being x. Otherwise, if x lookup this in here, lock returning from here, lock search mode binary is equal to x, then x. Otherwise, x lookup and just this bit, but now returning from next lock, and again I want search mode binary. Close if. Yes, so we're getting x's, but we're not done yet. Keep going. Okay, and this one's about to, oh yeah. 1820 is an x. Oh, I don't like that. Okay, so then, so let's do that differently, I guess. I let A be x lookup, all that stuff. No, never mind. This works. This works, this works, this works. Okay, so then we're going to match x against this 0 minus 1. Okay, and then I'm going to mark off the ones that I'm done with, so I'm going to say if this is equal to blank, and that, otherwise, oops, then blank, otherwise that. Sorry, wrong place. And that, otherwise blank. Okay, good. So then if I say I'm done with that one, yeah, we're good. And let's just put on a color scale. Right, actually I'll put the other way around. Yes, good, okay. So then, now let's see, this is, yes, this is turn 0, so that's okay. So that's okay. So then we're going to say countifs, this hash is this ref. Okay, fine, that's good. because this one needs to be an array. Good. Alright, so then we want to first figure out all the places you can go to next based on this, which is going to be xlookup this in location lock returning from. Actually, no, let's do it slightly differently. So then, yeah, we're just going to have okay, so then we're going to have, what are we going to say? We're going to say this plus this, but then we're going to want to say if that arrives at something pointing the opposite direction. So we're going to say xlookup that in here, returning from here. I'm going to say, is that equal to this? Sorry, no, is that equal to minus this? Because if so, we're sending ourselves to point back in the opposite direction. So from 101, you go to 202, and if you go down and left from there, you're saying that's bad. Yes, because that sends you back, but you're also saying if you go up and right from there, yes, that sends you back too. Okay, good. So then I'm going to say if that, then number 0, maybe. Otherwise, yes. So you can go to 103, which is here, or you can go to 103 is here, or 303, which is here. Yes, good. Fine. So then I think I can say let's choose rows from here, all 5, including the no change next, of match, no, not make array, match this hash against this lock. Oh, how are we going to get rid of the ones where you can't go? Oh, and I need to figure out if it's getting complicated. Match that 0. Oh, I don't have choose rows. Oh, it's super annoying. Right, fine, never mind. Alright, so from to equals to call if, no, first just to call of, no, sorry, from is yes, is if this, then this, otherwise 0, 3, so that gives you 6076, yeah, which is slightly less than 4 times, okay, and then to call this 3, which matches good. So that's the from and to. So then, yeah, that's fine. Oh, except I also want to check if any of these. Okay. So let's say let A be all that stuff, and then if. No. I want to say if error. No, I just want to say B match A against this 0. And I'm going to say A over B times B, which will make it error out whenever. Oh no, you didn't like that at all. Ah, sorry. Oh, that's exactly wrong. Oh, this is super irritating. I need an if error, and I need an is error or is number or something. But I don't have anything like that. Okay. I do have a not, don't I? No, I don't have an. Oh God. So, do I rept? I can do a really hacky workaround. I really don't want to be screwing around with this stuff now. Alright, never mind, just go back. Let's just do this. Let's copy value, paste these, and let's do match this against block 0. You cannot go to these places. Okay. So these are the actual froms and twos. I think, I hope. Alright, and now that I've value pasted, I guess I don't even need this anymore. Yeah, I don't need it. Right, so now I'm going to say to call if match this hash against this block. No, other way around. If match that against that 0, then this is just going to be either it'll give a number, in which case it's good, or it'll give an error, in which case it gets dropped by 2call, which is what I want. So if that, 2call 3. Good. And then I also want to wrap that with unique. Okay. So hundreds, but not thousands of places that Lana could end up. Alright, so now I want to move this along, and then I want to say sum square. I still don't have sum somehow. So there are 20 places you can get that one. There's only one place you can get this one. Perfect. That's exactly what I wanted. Okay, so now custom 0 minus 0. That, right. So the one place you can get this is where? Sorry, I missed it. Here. Okay, so here, I'm sorry, that is the third one up. So here my location has to be 1919, if I do vaguely remember. So now I just have to get down to the bottom of all of this. Some of these are very big. Okay. And then, sorry, what the heck? I just a bunch of X's here so that I have somewhere to scroll down to. Then we'll go find it again. Hope this gets faster. Okay, here has to be 1919 equals 1919. Okay, and then to the right of that, we just keep the old formula. Let's make this yellow, I guess. And then to the left of that, I want to say to call if match the destinations against this hash 0, then give me the origins. Yeah, 3. So that's the places that could get you there. But now I want to say let A be that, and I want to say if match, what am I going to say, A against this 0, then A otherwise nothing. I need to call that also. Well, let's not to call it yet. Yes, good. So then we'll to call that by 3. Ooh, what? Sorry, comma 3 in the wrong place. Okay, good. Okay, so now there are many fewer places. Oh, sorry, gotta also have a unique, thank you. Okay, good. So now there are many fewer places we can be, and now we're in row 819. So now I want to point this count to row 819. Oh, you didn't like that. Sorry, I haven't copied all the way across. My bad. Okay, and now... so sorry, shoot. Yes, this one I've done. So now these two both also have unique points. So first it's this one, which is the 5th down, 2, 3, 4, 5. So this one has to be 27, 23. Okay, I'll make that yellow again. And we have another one that is pinched also. That's this one, yes. And then we also have this one, and that's the third. No, we've already done that one. Where's the other one? Here. This one. There's only one there, another one there. Yes, good. So that's the 4th one. And in that position, it's 17, 21. And that's in column AD. Oops. There we go. AD. 17, 21, I think I said. I hope I said. Okay, so then again, to the right of that, we just propagate as before. And then to the left, we're going to go with this. Uh-oh. Now you're telling me there's nothing from there that will get you to 1721. Well, that does not add up well. Oh, right. Sorry, because I have to point it at the right place. Yeah, this. Hash. Oh, hash here. Phew. Okay, so this is definitely coming together. Somewhat, at least. So anyway, back to M. Yes, okay, good. Alright, so now we are in row what? 1596. I'm sorry, we've done those 3. Now, 1596. Alright, so this one now has only 1. And that's it. Okay, fine. There's that, it's here. So, oh, that's 1721 as well. That's weird. Okay, so you gotta get back to 1721. Why? I guess that can make sense, yes. Okay, so come up to here. 1721. Make it yellow. Okay, then we need to go to the left of that, which is this. And now this one has to point to whatever the heck row that was. 1596, thank you. 6. As far as column M. Okay, so we're still not fully pinched in this part, but we're definitely getting there, and this part is good. Okay, so now, wait, sorry, so what row are we in now? We're in 2, 2, 3, 4. So now I think I can, wait, sorry, now I gotta mark off the one that I did, that's that one. Yeah, let me just change this to if this equals x, then blank, otherwise some square. That'll make it easier to follow. Okay, so now my smallest is 2, but if I change this to, what did I say, 2, 2, 3, 4? 2, 2, 3, 4, yes. So let's do that, 2, 2, 3, 4. And yes, there is another one that only has 1 position now. Which is where, please? Oh, there it is. Okay, and that is the 4th position. 2, 3, 4, which is 1925, I think. Yes, 1925. Okay. Sorry, right. Yes, I do like that correction. I rarely like to be offered corrections, but I do like that one. Okay. No, I don't want that. Let's just put a bunch of x's there, and then grab the formula that I actually want, which is one at the end. Okay, so we still have loads of possibilities after that, but fewer before it. Where are we? Yeah, this is the going backward one. Okay, fine. And we're pointing at 2, 3, 4. Okay. 2, 2, 3, 4. Okay, we're getting there. Alright, so now we're in 2593. And wait, I gotta strike off. Yeah, I did strike off. Okay, good. 2593. 593. Okay, and yes, there's another one. And it's right here. You got a unique position in 17, and that is in the 6th row. And that is, let's say 1919? Yes, 1919. Goes 1919. Loads of possibilities after. It's fine. And then 4. Two, 5, 9, 3. Okay. Getting there. So now we're 3, 3, 6, 3. Three, 6, 3. Okay, now we've got this one. There's only one position, and that is here in 10th position. So that's that one. That's 1919 again. Weird. Okay, fine. No, wait, what? No, that's not good. That's not good. In that case, that's the one I've just done. What? Okay, that is definitely one I just did. 3, 3, 6, 3. 2, 5, 9, 3. No, wait, what? Yeah, no, 1919 here. Yeah, okay, so that is, in fact, picking up both of those. Is it? Yeah, okay. So this is what I was afraid of, that it might, in fact, be slightly differently constrained. Oh. Alright, well, I guess I gotta work on this one now. Sorry, the last one I did, that was this one. And in that one, it needed to be in 1919. Yeah, that's going to pick up both of those in 1919. Fine, so that's done. And I'm going to have to try 2 different possibilities here. So you're either going to get this one, in one of these 2 places, fine. And that's the second one, so it's 2018 or 1919. Let's try 2018 here first. Equals 2018. It was in that position, right? Yes. Or 1919 in the next position. Okay. Here we go. Okay, so still loads of possibilities after, but that's fine. Now going back. We want 3, 3, 6, 3. 3, 3, 6, 3. Okay, the question is, does that leave anything unable to be picked up? Sorry, where were we? 4001. If leaves this one with only one option. Alright, well, fine. I'm just going to highlight this in yellow, as this is the one where I may have to revisit which one I did, but okay. So now it's this one. I've done this one, so fine. But this one now can only be done. Wait, where? So there's one. Where is it? Oh, here it is. No, here it is. Good. Okay, and so on that turn, that's turn 3. You have to be in 1723. Okay. You already are, so that's uneventful. Fine, move on. Oh god, that leaves another 2. Okay, so yeah, here you can either, I guess you just go with the banana or you don't. Okay, so then I think going for one of these is either going to stop you from getting this 13. So, alright, here it is. Let's try 2018 in this turn. No, wait, let's try 1919. Next turn, what's this? Equals 1919. I'm hoping, because I'm taking the later one, that will tell me that I'm more restricted, that I can't do that one. But we'll soon find out, won't we? Okay, so that does that, and then, sorry, we're in row what? 4, 3, 8, 2. So now we're going to point this just from here on to 3, 8, 2. And I'm hoping, no, it still leaves me with 2 possibilities to get that one. Or in theory I could get it before, but I guess that would lock me out. So let's try getting it. Wait, hang on, sorry, I can do the before part of this logic as well. So for this, I want my go across to M, and then pointing at 4001. Okay. So then here, we've moved to the later one. Here we haven't. Yeah, okay, so now you can get this apparently in one of 2 positions. You can get this in one of 2 positions. So, I don't know. Yeah, it's 2018 and 1919 again. So I guess we just keep going back around to 2018, 2019, 19. Alright, I don't know, whatever. Let's just say we do 2018 on this turn. Wait, yes, there was instructions about this. You want to get the bananas as soon as possible. Banana is an essential... I think there is a tiebreaker for this. Banana can also option yes. Banana say yes. Banana say yes. Stay say yes. An uncollected banana lands on an X, yes. Starting grid, turn 0, yes. Okay, collect it as early as possible while meeting the condition. Yes! Okay, perfect. So then I just have to make sure that I did this one as 2018 and not 1919 in the next one. Which I did, but this one I didn't. I did it the wrong way around. So this one should be 2018. And then this should be the forward going from there. And this is all backward from there. Good. Okay, and then finally, I think it is finally now, we're going to collect this one as soon as we can, which is 2018. Equals 2018. I'll make that yellow. I guess it doesn't really matter where you go after that, because I assume you stop after that, but just for completeness I'll do that. And then this back to column M. My concern is that there are some ambiguities in the path here, 4382, but it may be that they always correspond to, you only have to give whether you take an extra move or don't. So maybe they always work out the same way. I'm not sure, but okay. So the answer format. Answer the binary string when you get a turn which you collected at least one banana and 0 turn. Oh, okay. That's not at all it. Okay, fine. The final digit should be 1 to indicate the last banana. Okay, fine. Alright, so then that is just going to get zeroed out. This is just going to get zeroed out. This is just going to get zeroed out. And so then this is it. It's sum of that. Oh, I don't have sum still. Sum square of this, and I'll include one more just so that it becomes a range and not a dynamic array. Alright, so there. I think this is the answer. Moment of truth, let's go! It's not, oh, wait, there's a 2 there. Whoops, yes. So we'll say minus minus, that greater than 0. No 2's in our binary string, please. Oh, no! Impossible! Impossible! I don't believe it! Oh, that makes me so sad. I had it. I was sure that I had it. Okay, so I cut it off there because I did spend a few minutes trying to debug after that without any success, but I was pretty sure I had the idea basically right because the setup of the bananas was so specific to have a unique solution that I figured the fact that I had found a constrained solution had to mean I was kind of there. So I exchanged some messages with Harry after this. Turned out there was just like something off by 1 in his answer, but in fact my answer was good. So now I had to come back just to bring it. Oh yeah, and he bumped it up to an hour too. But anyway, so I kept my number here. Kept the whole thing because I wanted to do some debugging on it. So now hopefully I can. Oh, and look at that! I get bat text and len b. Thanks, Lana. That's so generous of you. Anyway, that is that. I also just wanted to quickly show you, as part of the message I was exchanging with Harry, I made this. I was trying to convince myself whether what I had made was in fact right or not. And the way that I did that was by making a visualization kind of like that one I showed you in the first video. So here is Lana surfing around the whirlpool, gradually gobbling up all the bananas and saving the day. And as you can see, it's like, you know, this is the banana that you started off right next to and you don't get it until much later. And then this one that you're right next to toward the end, you don't get it until a whole turn round. So there are some non-intuitive things. But anyway, that's what it looks like. Harry, hats off for a truly amazing case. And I am very satisfied to have conquered the final boss. And even though I call it the final boss, I do plan to go back and tackle some of the other Michael Jarman divine challenges later. But oh yeah, I gotta check my. Ooh, I got 1,000 points for that. I'm now an expert. Yes, 2 out of 2 divine curated challenges. Yeah. Oh, I'm almost done with advanced actually, but there's still a bunch of expert, a bunch of divines, and a few easies. So I will probably play around with this some more. But now that I've won the final boss battle, I think I'm gonna let myself take a bit of a break. Thank you, Harry, for a super fun case, and thank you for watching. That's all I got for today. See you next time.